We have a circle here, and we want to find the center and the radius, which means we need to put it in the standard form x minus a squared plus y minus b all squared is equal to r squared. Center AB, radius r. We can do this by completing the square. So I've got x squared minus 8x. I can write that as x minus 4 all squared by halving the 8, and I need to minus 16. So that bit there is x squared minus 8x, just in a completed square form. Same for y squared, it's going to be y minus 3 squared, because it's y squared minus 6y, so I have the minus 6, and then I need to minus 9. And then minus 20 equals 0. So if I tidy that up, I'm going to get x minus 4 squared plus y minus 3 squared. Minus 16 minus 9 is minus 25. And then minusing 20 will give me minus 45. So this is going to equal 45. And the center is then going to be 4 and 3. And the radius is going to be root 45. I could write this in simplified surd form. It'd be 3 root 5, but I think this is fine. We're told that the circle crosses the positive x-axis at the point A. Here we are. Find the equation of the tangent to the circle at A. So that's going to be this line here. Now, first up, let's find the point A. And that's A. We've got that y is equal to 0. So I can substitute in y equals 0 into the original equation or into this one here. I think I'm going to put it into the original one, because otherwise I'll have to expand the bracket. Well, actually, that would be better to expand the bracket. Sorry, no, to have it in this form. So I can say that x minus 4 squared plus, and then it's going to be minus 3 squared, it's going to be plus 9 is equal to 45. Now this is nice because this is this is in completed square form. So it's going to be x minus 4 squared is equal to 36. And x minus 4 is going to be plus or minus 6. So x is going to be, if it's minus 6, I'm going to get minus 2. If it's plus 6, I'm going to get 10. And therefore the coordinates of A are 10 and 0. So yeah, this was a good shout to use this one. Otherwise, you can substitute it into this full equation and then factorize. It's just, it's, I don't know, maybe that would be quicker actually. But both are okay as long as you get 10 as your answer. Right, next, we're still on our way to finding the equation of the tangent. We've got the x and the y values, but we don't have the gradient of the line. And that can be found by thinking about the gradient of the normal, or the gradient of the radius, because this is at 90 degrees. So we have A is 10, 0, and we have the center, which is 4, 3. I'm going to come down here now. So the gradient of the normal is going to be y2 minus y1 over x2 minus x1. And I'll pick this, I think, no, maybe I'll pick 0 minus 3 over 10 minus 4. That's going to be minus 3 over 6, which is minus a half. And therefore, the gradient of the tangent Because they're at right angles, it means that they will be negative reciprocals of one another, or equivalently, they will times together to give 1. So it's going to be 2. Now we also have when x equals 10, y equals 0. So we have the coordinate where the tangent touches the curve, and we have the gradient of the tangent. So all that is left to do is use y minus y1 is equal to m x minus x1 and substitute in accordingly. Y minus 0 is equal to 2x minus 10. And I could actually leave it like that, but I might as well expand it out. 2x minus 20. We're told in part 3 that a second tangent to the circle is parallel to the tangent at A. Find the equation of the second tangent. So if I take my tangent, and you can use a ruler, think about where this would be. It's going to be the opposite side over here. So we actually already have that it's going to be y equals 2x plus c. Okay, it's just what the value of c is. And we can use the idea of the gradient here. So I can see I'm at 10 and I'm going to go to 4. So I'm going to go minus 6. But actually, this is going to go through the diameter. So I can actually go the same again, the other side. Okay, we must have this in place because, yeah, we've gone from one end to the center, and then it's going to be the same again to get to this parallel tangent. So it's going to be minus 6, and this coordinate is going to be, therefore, the x coordinate is going to be minus 2. And do exactly the same to go from 0 to 3. I go up 3. So then 3 to go up 3, it's going to take me to 6. So it's going to be minus 2, 6. Minus 2, 6. Right, I wrote that down, but actually I can use this again. So y minus 6 is going to equal 2x minus minus 2. Okay, I've used y minus y1 equals mx minus x1 again. But that was useful. Y minus 6 is equal to 2x. That's going to become plus 2, so plus 4. Y will equal 2x plus 10. So that is definitely the best way of doing this question. There are other more complicated ways, but just think about it carefully. Parallel tangents, so there's going to be a line directly from one to the other. Think about the use of the gradient to get to the coordinate, and then use the fact that they have the same gradient. Finally, we're told that another circle has center at the origin O and radius R. So here, this circle lies wholly inside the first circle. So it could be here, could be here. Oh, that's too big because it's got to lie entirely inside. So it could just about touch, I suppose. Find the set of possible values of R. Right. Just going to get another sketch down and then put another circle on. Now don't forget also that we have the radius of the circle here, 3, 4. And so we can think about what happens if we draw a line from the center that goes through the origin, but then keeps going. Now, part of that line will be the radius of the circle from the origin to the outer part, because they're just going to touch. And so I need to think about the length that I have. And in fact, I can work out, I know that the full length, remember, is root 45. And now we also have a right angled triangle with length 3 and 4. So I can work out this length here as well. It's going to be 3 squared plus 4 squared square rooted. It's actually a 3, 4, 5 triangle. It's going to be 5. And that means for this particular circle, r is going to equal root 45 minus 5. And that's the maximum value of r. So we're actually asked for the range of values if it's entirely within. Now it has to have a radius greater than 0 to be a circle. So we're going to get that 0 is less than r, and this is going to be less than or equal to. So because it lies wholly inside the first circle, yeah, that doesn't mean. I think for it to lie inside the circle, it actually needs to be less than this root 45 minus 5. Otherwise, it could kind of partially overlap, but it's got to be wholly inside. So that is our answer. Whew.